Good morning. Today we are going to see the lecture number 50. 50. Problems in synchronous motor. Okay. So a three phase 400 volt 50 hertz 37.3 kilowatts star connected synchronous motor has a full load efficiency of 85% of 85%. The impedance the synchronous impedance of motor is zero point 0.2 plus j 0.6 ohm per phase. Okay, if the excitation of the motor is adjusted to give a leading power factor of 0.9. Calculate for full load 1 the induced EMF, 2 total mechanical power developed. Okay, so this is the first one. A 3-phase 400 volt 50 hertz 37.3 kilowatt star connected synchronous motor which having a full load efficiency of 85%. Okay, the synchronous impedance of the motor is 0.2 plus j 0.6 ohm per phase. Now if the excitation, that is excitation means the excitation which is available in the field winding will be adjusted, which will give a leading power factor 0.9. Now by using this data you are going to calculate the full load of induced EMF as well as how much mechanical power developed, because it is a motor which converts electrical into mechanical. So how much mechanical power will be developed? Okay, this is one of the university JNT University question. Okay, now I am going to solve the problem. First step, solution. Okay, you see the motor, it is a star connected synchronous motor, right? It is star connected motor. Okay, in star connected motor, you know the V line equal to root 3 into V phase. So therefore V phase equal to VL by root 3. See, VL means it is a line. Okay, VL by root 3. So how much VL? It is VL 400 divided by root 3. So can anyone tell me the answer? please unmute your mic and please give me the reply. 400 divided by root 3. It comes around to
230.9, sir.
94 volt. 230.94 volt. Okay, then the next step here, it will be a power 37.3 kilowatt star connected synchronous motor. That is, it is a output power. Okay, the output power which is given 37.3, as well as they have given the efficiency, it is 0.9. So we know that efficiency neta equal to output power divided by input power. Okay, output by input. So how much neta? Efficiency will be 85%. That is 0.85 equal to P out 37.3 kilowatt into 10 power 3 divided by input power. Okay, so therefore P in how much ma? P in how much you got it? Input power. So it is 88%. So it is 88%. Okay, so here it is 0.88. So how much P in? Efficiency is 88%. I changed the question. It is 88%. It is how much?
42.61.
42.386. I got 42.386. Please check. 386 kilo watt. You got this answer? P in? Students? P in is 42.386 kilowatt. Then, whether current is available in our question? Only voltage, power, efficiency, impedance, power factor. Only 5 data are available except current. So, the current to calculate, write down. We know that input power P in equal to root 3 VL IL cos phi. This is the input power formula. Now substitute the value. P in how much? It is 42.386 into 10 power 3, which is equal to root 3 into VL value, that is line voltage. Okay, 400 into IL, you don't know, into cos phi. Power factor they already given, it is 0.9. Substitute. So can anyone tell me IL value? How much IL? Therefore IL equal to, anyone? Please give me the answer.
67, sir.
67.97.
67.97, or we can take 98, because 978 or 979 you got it. So I make it to 67.98 ampere. 67.98 ampere. Okay, so this is nothing but full load current. Full load current, because we are taking full load efficiency value. By using the full load efficiency only, you are calculating the Pin, and by using the Pin we are calculating the IN. Okay, so since the machine, okay, the machine will be a star connected machine, so you note down here, since the motor is star connected, therefore the line current equal to phase current. Phase current means armature phase, which is equal to 67.98 ampere. Okay, then next step, next one. Now we are going to we are having the impedance, synchronous impedance value in our question. Z, yes, synchronous impedance will be Zs per phase, which is equal to how much? 0.2 plus j 0.6 ohm per phase is available. Now we are going to calculate the Zs. Okay, now we have to find out synchronous impedance in terms of magnitude. We have to do square root of 0.2 square plus 0.6 square equal to how much more? Zs equal to square root of r square plus jx, r square plus x square. Okay, that is the formula. So 0.2 plus 0.6 whole square. So what is the value? It comes around 1.
0.63, sir.
Not 0.63. It is 0.6. Sorry. Here, please change it here. I have done a mistake. Okay, 0.2 plus j 1.6. Okay, j 1.6. Okay, in the question it is 1.6. Please change it. J 1.6. So therefore 0.2 square plus 1.6 square. Okay, so what is the final answer? Zs how much? Zs equal to 1.6125 ohms. Okay, now we have to calculate impedance per drop, that is ER. ER equal to I into Zs. So I value is what? 67.98 into Zs value 1.6125. So can anyone tell me the answer of ER? ER equal to I into Zs, impedance drop per phase. How much my ER?
109, sir.
109.6 volt. 109.6 volt. Okay. Then okay, this is fine. Okay, ER equal to 109.6 volt. Okay, now by using this data we are going to calculate the first value will be induced EMF. Okay, induced EMF we are going to do. So how to calculate induced EMF? What is the formula here? Take induced EMF. Okay, induced EMF E equal to root 3 into E value. Okay, E means it is a excitation
You're doing now, man.
EMF per phase. Okay, so this is induced EMF. Induced EMF equal to root 3 into excitation EMF per phase. Till now you don't know how much your excitation EMF. Okay, now we will calculate the excitation EMF. You already know the basic formula for excitation EMF. Your question is mentioned about it is a leading perfector, right? So E equal to square root of V square plus ER square minus 2V ER cos of it is a leading power factor, because in your question itself they have clearly mentioned it is the leading power factor. Now can anyone tell me the formula for leading power factor in terms of excitation EMF per phase? Cos of what I have to write here?
Theta plus phi.
Theta plus phi. Okay, theta plus phi. You don't know the theta value as well as you don't know the phi value. Now how to calculate the theta and phi? Okay, generally the theta will be an angle between a resultant EMF, that is ER, and current. Okay, you take down here, you find out the theta. Theta equal to tan inverse of XS by RS. Okay, so tan inverse of how much XS? XS will be the synchronous reactance 1.6 divided by resistance value will be 0.2. Close the bracket. Now find the answer. How much? Theta value. Theta equal to how much? Tan inverse of 1.6 divided by 0.2. Theta is the internal angle between ER and current. Theta value how much? Anyone? It is 82.87 degree. Okay, 82.87 degree. And phi will be a phase angle. Phi is the phase angle between voltage and current. Okay, between voltage and current. So you know the power factor cos phi equal to 0.9. In your question itself it's clearly given 0.9. So from this can you calculate phi? Phi equal to cos inverse of 0.9. So how much phi? Phi how much comes around? 25.84 degree. Now substitute all the parameter in our equation. E equal to square root of V value will be the V is the phase voltage. That is the first step which I done. 230.94 whole square plus ER. ER is already calculated 109.6 whole square minus 2 into 230.94 into ER value 109.6 into cos. Now substitute theta and phi. Theta is 82.87 plus phi 25.84. Okay. Now close the bracket. Please give me the answer. Students, please give me the answer. You have to give the answer. E value. Sarthak. Sarthak Das, Grishma, Ashu Anand, Anirudh. Give me the answer. Jibran. E value. E value how much? You got it? E value. What's the final answer? E value. Excitation EMF per phase. Nishal Dinesh.
Sir, 285.6.
285.79 volt. Okay. Now substitute. You know the formula. Induced EMF. Therefore, induced EMF. E suffix induced EMF. For EMF, I have taken the notation E. E equal to root 3 into excitation EMF. 285.79. What's the final answer? It comes around 495 volt. 495 volt. Okay. Then second subdivision. As per your question, second subdivision, they are asking you to calculate total mechanical power developed. Okay. So the formula for total mechanical power, P mechanical equal to power input, that is P in minus total copper loss. Power input you already calculated. Input power, how much your input power as per your problem? We already calculated, right? Here it is done. Input power 42.386. Okay, so this value substitute here. 42.386 into 10 power 3 minus total copper loss. You know the copper loss formula, 3I square into RA. 3I square RA. Okay. I is nothing but your line current, or we can say, since it is a star connected, the line current is equal to armature current, that is stator current. Now substitute the parameters. 42.386 into 10 power 3 minus 3 into I value. I value, how much I value? 67.98. Substitute it. 67.98 square into RA. RA will be the resistance value. Resistance, it is already given in the impedance value. It is 0.2. 0.2. Now give me the answer now. Therefore, P mechanical. Please give me the P mechanical. P mechanical how much? Mechanical power.
So is it 39613?
39613. Okay, 39 point 39 point 39.613 kilowatts. Okay, this is mechanical power. This is one 10 mark question. Any doubts? Any doubts in this above problem? Now how to draw the phasor diagram for this problem, because in your examination if I mention in the question for a CA3 sketch the phasor diagram for leading power factor, means immediately you have to draw the phasor diagram. Once the calculation done, you have to draw the phasor diagram. Okay, the phasor diagram, the split up mark will be 3 marks for to draw the phasor diagram. By using the scale and pencil, you have to draw a phasor diagram. I don't know who is that fellow who is coming now. Okay. How to draw phasor diagram? First you have to point 0, then you draw voltage V. V value 230.94 volt, that is V phase. Okay, V phase 230.94. This is my first step. Then angle. Now we are going to plot the current. Okay, plot the current means you have to keep your protector here and measure an angle of, that is nothing but phase angle, that is phi. Okay, phi you have to plot. This phi value will be 25.84 degree. Okay, this is my current. I equal to 67.98 ampere. Okay, this is phi. Phi is nothing but phase angle between the voltage and current. Okay, and another, you have to plot an internal angle. Okay, now you keep your protector in this direction, that is you have to keep your protector, for example this is your protector. Okay, this is 90 degree. Okay, so you have to keep the protector towards the I direction. Okay, in this direction you have to keep the protector and measure an angle of, because the internal angle lies between the reactance term, synchronous reactance term, and current. Okay, so the angle will be from I, you have to measure an angle. The angle it will be theta equal to 82.87 degree. Okay, 82.87 degree. So once you measure an angle, then you draw a line which starts from origin. Okay, which starts from origin. Wait. This is ER. ER. ER value we already got it. 109.6 volt. Okay, so once you plot ER, then you join this V and ER phase. Okay, this line will be E. E equal to 285.79 volt. Or understand? The first step, you have to draw a voltage. This is my first step. Second step, you have to measure phase angle. Third step, draw line current. Fourth step, from the line current you have to plot internal angle. Fifth step, by using internal angle, draw ER. Sixth step, by using the ER, join the lines between the ER and V phase. That is nothing but E value. E value will be an excitation EMF per phase. So the plotting of all the parameters from the synchronous motor, which will be very easy by using the phase angle and internal angle. Only these two angles are sufficient to plot all the parameters. Okay, if you know the voltage, if you know the phase angle, if you know the internal angle, then it is very easy. Just you have to join the lines, that's all. This is the phase angle. In the real-time system, okay, if you want to measure, for example, one motor is running, okay, now you are going to measure the phase angle. Means, can anyone tell me which instrument you are going to measure this phase angles? This diagram, it's there, right? Okay, in real time, which instrument you are going to use to measure this phasor diagrams? Which instrument? Can anyone? Because in real time, to measure the voltage you need voltmeter, to measure the current you need ammeter, to measure the speed you need speedometer or tachometer, to measure the power you need wattmeter, to measure the frequency you need frequency meter. Like that, any meters are there to measure this phasor diagram. Because when the motor is running, as a student or faculty, we don't know what type of connection it will be inside the motor. You can't open the motor and you can't see. Okay, so it will take more time. To save our time, which instrument will be used to measure the what type of connection will be there and what type of phasor diagram now at present the motor is running? Can anyone guess which instrument? Instrument to measure the phasor diagram. Instrument to measure. Anyone? Anyone give me the answer? Anyone? Students? Because you have studied what is that, DC machines, transformers, and you are studying a control system, as well as you are studying that, what is that, measurements subject. So which instrument? The instrument which is used to measure the connections as well as the phasor diagram structure will be power quality analyzer instrument. Okay, so this is the instrument name. The cost of the instrument, it is very high. Okay, it comes around 4.5 lakhs or 5 lakh rupees. The cost is very high. Okay, nowadays, for example, in your streets, okay, you are seeing the transformer, right? Okay, if any problem will be there, if you are calling the electricity board department, what is that, the technician will come and check. Okay, he is having that instrument, power quality analysis instrument, because the government is spending lakhs of rupee to buy this instrument to save the time, as well as it is one of the safety precautions to measure the parameters without opening or without damaging the existing equipments. So this equipments will be used in most of the electricians, they are having this equipment. Okay, power quality analyzer equipment for three phase they can use. For single phase they can use the handy type instrument, that is cost is around 1 lakh rupees. Okay, this is the equipment, power quality analyzer equipments. If you want to need a more data relevant to this instrument, you can just browse it in net and you can go through it. By anyway, I am going to explain this instrument by upcoming classes. Okay, normally it will be used for research and real-time purposes. Okay. Any doubts?